Good morning, everyone. Welcome back to lesson 2, Apply Thermodynamics KM 21603, semester 2/C 2020 and 2021. So last week we have mentioned about our meeting hour, our syllabus, reference books, sustainability in applied thermo. And now this week we're going to touch about review of fundamental of thermodynamics. So I can't do that last week because I need to have some feedback from your Google form. Anyway, for those haven't joined our WhatsApp group, please scan the QR code here and you can get the latest notification about this subject. Okay, so for the lecture delivery methods, so far we still stick with online. Recently we have found some of the problem that some of the lecturer prefer to face-to-face, but the space of the lecture hall is not fit to follow the SOP. So to make everyone comfortable and able to listen to the lecture comfortably, so we stick on the online. So where to download the notes? I upload the notes in Google Class Code and the Smart V3. So you can log in the Google Class with the code, the red one, the code given. You can get the lecture notes, tutorial, and along with the attendance link. Smart V3, you can get the attendance link. And again, I advise you to have the Google Classroom with you. Video, because some of the students say the space is too large for a video for them to download. So I created a YouTube channel, Y2 Farm. Please refer to Apply Thermodynamics for your lecture notes, okay? So here is the feedback from your survey form. More than half think this subject might be very challenging. But more than half of you think this must be very interesting. Only 1% think this is simple. I would say this subject is quite challenging, but this is interesting because you are dealing with the real application. We are not able to, because you might know how to drive a motorbike, you might know how to drive a car, you might very common see some diesel engine and petrol engine, so you can finally know, oh, okay, inside the engine there's something happened and this is why. So I would say hopefully this subject can make you gain some interest in the engine cycle. What is your expectation or suggestion for the applied thermo? Yes, for the applied thermo, okay. So challenging. I would say you won't learn anything new if the thing is so dull and not challenging at all. We want something fun and challenging this time. Can apply them in real life application, yes, but most of the equation we still link with the perfect condition. Why? Because once you know the perfect condition, and then when you really calculate the real one, then you can compare what is the problem, how you overcome on it. More tutorial with answer. Yes, tutorial will be given every time we have finished a chapter or a sub-chapter. If the lecture notes attached with a tutorial, please try it and we will have a discussion on the Friday. So the attendance link will be given on Friday as well. And the discussion answer will be given in video form, but only available for 2 weeks. So this is to make sure you guys really spend some time within these 2 weeks to really study on the tutorial. Okay, more video. Yes, we are I prepared some video for our lecture along with the lecture notes. So if you go through it and you try your tutorial, there's no reason that you fail your subject. A complete lecture notes as guide, yes, yeah. Each chapter I will attach a lecture note with for you so that you don't have difficulty to do the revision. Some of you prefer face-to-face for test, midterm, and final. Some of you prefer everything online. Well, for the final, yes, we have to face-to-face. For the midterm and test, we still can choose either online or face-to-face. But personally, I think to ensure everyone in a safe condition, I will still stick with online. If there is some changes, I will let you know. This is because I'm not advised to take any vaccine at this moment. So I don't want to have any risk to spread any virus to you if I have it, or you spread the virus to me. So and I think you are not primary school student, and I respect all of you as an adult. I need to tell you clearly here. When I say I respect you as an adult means I trust you, not going to copy from your friends. But if you think you are not matured enough, you're still not confident, and you want to copy it, I can assure you, you can copy your midterm, you can copy your test, but you're not able to achieve good marks in your final. That's what, based on my experience. Yes. So my advice is going through the lecture notes, video, and tutorial. And then for the midterm, please respect yourself and as an adult, because I don't want to check everyone uh, just like a secondary school student. All right. Provide full record lecture tutorial in YouTube. Yes, I'm going to do that, but the tutorial only within 2 weeks, only active within 2 weeks. So please remember on it. So for example, Tuesday, I uploaded the lecture notes and the tutorial. So we are going to discuss on Friday. Try it within that time because you have some understanding. So when you do the practice, doesn't matter you have some mistake. So on Friday, when I upload the tutorial, from Friday onwards, within 2 weeks, the tutorial video active for 2 weeks. So there's no reason for you to say that, oh, I don't have time to do the revision. So once you can gone through so many times within these 2 weeks. So you won't delay your progress. Okay? Don't give too much assignment, so more time to study. You can ask your senior. I only give 2 assignments. One is more about open-ended, another one is calculation. This is to make sure that you don't just rely on one assignment. If you can't do it, you're killing yourself. But if you have 2, you have some backup there, right? So, and again, some of my students complaining that I don't have much tutorial. I think understanding is more important than you practice like I practice you like a monkey to keep on practicing the things. Once you remember, during the lecture, I will give you some example, and I also give you tutorial. So you try to understand from there, you're able to sort out your tutorial, your test, your midterm, and your final. There's no point I give you too much tutorial, but you don't have, but you are trying to like aim score some of the question. This is not true actually. I actually try to do that. I give a similar question to the student, but in the final, they're still not able to do so. So my recommendation is I strongly recommend all of you to try the tutorial, the example in the lecture notes. Yeah, do that if you want to score. Okay, So I also did make a feedback question about what you have learned in your from your engineering demo. Okay, but yeah, you told me that you learn about the energy balance, you learn about zero law, first law, second law, an open and closed system, enthalpy, but I'm not sure about entropy and psychometric chart. So because if you learn about simple refrigeration, you should know how to use the psychometric chart. But and yet in the feedback form, only less than 10% tick on it. Anyway, probably I will touch a little bit on this. Don't worry about that. I'll make sure everyone know about it, okay? And some of you asked me about the definition about heat, definition about thermodynamics. Basically, thermodynamics is a relationship between heat, work, energy. So you, for example, heat engine. I heat up the engine create work and have the energy, right? What is first law of thermodynamics? First law of thermodynamics, no, the second law of zero law of thermodynamics. It's very simple. For example, I put a hot Milo and I put an ice in the room temperature. So we have three systems here. Room temperature is the surrounding. Hot Milo, 1. Cold ice, 2. Right. So it will reach equilibrium. The heat from hot Milo will reject it to the room temperature and to create the equilibrium. The ice will get melted. Why? Because to create the equilibrium, the ice melted, become liquid, and then in order to have the balance, or we put the meat in the refrigeration system. So the meat will reach the equilibrium in the system, in the closed system of the refrigeration to achieve the equilibrium frozen condition. So this is second law of zero law of thermodynamics. Okay, the first law is there's no energy can be destroyed or created. The energy is there. It can be transformed to many forms. So for example, heat engine, we change the chemical energy that can, anyway, the chemical, we burn it and then we become heat and then become heat and then push the piston and become work. And some of the work turn to heat loss. But in the first law, they never consider the direction. So for example, our light, we on the light, the electricity create the light for us, right? And at the same time, it will create some heat. Can I use a candle to heat up the light, to heat the light, the lamp up so that it will light just like the electricity supply and light up the bulb? No. So for first law of thermodynamics, there are some weaknesses there. Okay. So before we go through that, we touch a bit about some fundamental things you should know. So for example, why we need to learn about surrounding and boundary in a system. For example, you have a big steam power plant. You have the steam boiler, you have the heat exchanger, you have the what else? You have the, maybe you have a reactor. So there are so many components there. You have to fix what is your system, which part you are looking at. You have to have the boundary. Why? For example, you have the open system, they might have so many inlet and so many outlets. If you have fixed the boundary, we know that we only focus on this inlet and these two outlet, or this outlet, not the other one, so that you won't confuse, and you focus on the one that you are considering at. Okay, closed system. Of course, once you have a closed system, you have the surrounding, so you won't be confused on, or in other words, you are clearly identified what is the energy, what is the changes to the system, where is the factor change energy in the system. Okay, so I'm sure that you learn about kinetic energy, potential flow energy, and internal energy. Right. This is very important. We are dealing a lot of perfect gas condition, especially engineering thermal, because we are trying to make everything imperfect. Once you know the condition in perfect condition, the good thing is once you know the perfect condition, when you go to the complicated or actual condition, you can compare and you might know what is the problem. So we are still learning the fundamental, the basic things. So the perfect gas is the gas at temperature negative 273 at a very low pressure. The vapor of the fluid tends to obey PV over T equals to R. R is a constant. Specific heat capacity. What is specific heat capacity? You need to know that is amount of heat required to raise the temperature of 1 degree of 1 kilo component substance. Heat, a form of energy transfer from one body to another, from higher temperature to lower temperature until to be in thermal equilibrium. So I would like to share this because I'm sure some of you might be confused on when should the condition is positive or negative. Imagine this is a system. If you try to supply heat, you try to heat it up. We are given the heat to supply the heat to the system. So this system gain heat. So that's what is positive. After 3 hours, we leave it like that. Your hot Milo turn to be room temperature. Where are the heat gone? The heat rejected by the system. Okay, so the heat lost from the system. So the Q is negative. The work is a force, try to push it for a certain distance, and you have the work. So if the work done by the system itself is negative, but if you supply the heat, you supply energy to the system. Okay, the work input to the system, so the work is positive. Okay, so another things you need to know about it is these few things. Isothermal, iso is same, thermal is heat. So when heat is linked with temperature, isn't it? So isosame, temperature remain constant. A change of a system which the temperature remain constant. So the changes of the temperature is equals to 0. Adiabatic in this case means there is no heat, no heat flow can go into or release from the system. So normally this system is a closed system. So your delta Q is equals to 0. Isobaric process. Iso is same, baric is pressure. So pressure stay constant. The pressure is constant. Isochloric process, a system in which constant volume. Isochloric constant volume. Delta V equals to 0. So like I mentioned to you, first law of thermodynamics they don't have the direction. So for example, the hot coffee reject the heat. A cup of hot coffee does not get hotter in a cooler room, right? And transferring heat to the wire will not generate electricity. Transferring heat to the pedal wheel will not cause it rotating. When you rotate it, it will create the work and the heat loss. But if you supply the amount of heat, we calculate and we change everything to heat it up, it won't cause the pedal to rotate. So this process cannot occur even though they are not in violation of first law. You see, the first law, you don't have the direction. So the first law is some of the process occur in a certain direction. You can't be reverse direction. So a process must be satisfied in first law and second law to be proceed. All right. So, okay, the second law, to identify the direction of the process, the second law also assert that energy has quality as well as quantity. In first law, we only mention about it not able to destroy, it should be the same, the total, but it's not mentioning the direction and the quality. The second law of the thermodynamics also used in determining the theoretical limits of performance of common use in engineering system, such as heat engine and refrigerator, as well as predicting the degree of completion of chemical reaction. Heat engine. So this is a very important things. We are talking about heat engine, about half of the subject. Yeah. So heat engine is a device that converts heat to work. They receive the heat from high temperature source and then they convert part of the heat to work. So they reject the remaining heat to the low temperature sink, for example in atmosphere, and they operate on a cycle. If you achieve these 4 criteria, you are dealing with a heat engine. Heat engine and other cyclic device usually involve a fluid to and from which heat is transferred while undergoing a cycle. This fluid is called the working fluid. For example, refrigeration system is a reverse heat engine. Okay, we use the refrigerant to transfer the heat. And again, that is reverse. For the heat engine, so we look at this one. So when we turn it, we have the heat loss, but we try to apply the heat, the pedal won't work. Right? Work can always be converted to heat directly and completely, but not reverse. But the reverse is not true. Part of the heat received by the heat engine is converted to work, while the rest is rejected to the sink. Okay, so difference between, okay, so I'm not sure you learned about entropy before, but definitely you have learned about the enthalpy. Enthalpy is denoted by H, refer to the measures of total heat content in the thermodynamic system under constant pressure. I think you should be familiar with the H. And if you refer to the entropy, we normally use S to refer the disorder in the thermodynamic system. So what are these means? Actually, enthalpy is describe the energy it takes for a substance to change from one phase to another. So if you have negative changes of enthalpy, it means that your system is decreasing the heat content. For the entropy is dealing with the disorder of the particles. So the changes positive means your orderliness of the system decrease. So what's that means? It means that, in short, enthalpy look at the energy needed, whereas entropy look at the organization, the particle themselves. So let's say, so what happened when entropy increase? Entropy increase when the substance is broken up into multiple parts. So for example, when your solid, your ice turn to liquid or gas. So the particle, the molecule is not stick together. Your entropy increase. The process of the dissolve increase entropy because solute particle become separate from one another when one solution is formed. Please remember that the entropy increase as the temperature increases. So when the temperature increase, so the entropy increase. This is because the orderness of the system is getting messy. They are losing. So they are high disorder and low energy. Why entropy higher in equilibrium? Since entropy for a spontaneous process increase till it reach maximum, and equilibrium change in entropy is zero. Hence, entropy will be maximum at equilibrium. So, and I think this chart, this chart have a clear statement. So, well, let's look at the TS diagram. When the S increasing, see the first one is compressed liquid and it changed to the superheated vapor. So it means that the higher the entropy, the higher the temperature, it will change to, it will change your system into more disorder. Okay, so I think this chart show clearly, and this is the temperature entropy and entropy diagram that you are going to deal with it mostly in chart, not in the diagram, to get some of the information on it. Shown above are the temperature, entropy, and entropy diagram. And again, enthalpy is H, entropy is S. Okay, the HS diagram called molar diagram. It's very useful for the steam power plant problem. We are not going to look at it until I think chapter 7, I think. Yeah. If you look at the saturated water temperature table, I think mostly you deal with specific volume, internal energy, enthalpy. And there is another one is entropy. So if you look at it, as the temperature increase, the entropy increase. Can you see that? So this seems like agree with what we have stated here. High entropy means high disorder. Entropy increase and the temperature increase. Yeah. And this is the superheated power water table. And again, the S is the entropy. So yeah, actually, basically for this semester, we are going to deal with the entropy a lot. So try to have a look on it in your reference book, and I'll see you next week. Okay. Yes, because this is still a revision, so we don't have any tutorial. We will only have tutorial next week. Okay. Stay safe. See you soon.